Hi students, now we are going to explain a topic called torque acting on a body. So this is from the chapter motion of a system of particles and rigid bodies. Okay, now I will take a rigid body in the form of a cylindrical rod. I place it on the horizontal surface. Okay, I have placed it on the horizontal surface, and now I have tied a string along the length of the rod. Can you all see? So the string is along the length of the rod. Now I am going to pull the string. What happens to the object you see now? Is it moving? You tell me. Yes? Is it moving along the length of the string? That means the force is acting along this string. So object is also moving along the same string. Okay, now I will repeat this in a different way. I will take a rod and I will fix one end of this rod. Okay, I will fix one end of this rod to the cylindrical rod. And now you see that now the same string, okay, the same string, I will pull it in a different way. You can see from there, so this small stick indicates the direction of the position vector of one particle, okay, one particle on this rod. So I will keep the string at an angle like this, okay, at an angle like this I have kept. Now if I will pull the string means the entire rod is going to rotate like that. Now I will keep the string in the downward direction like this, downward direction, and I will pull the string means you can see that the force is producing a rotational effect. The other direction also, I will repeat once again, the other direction also you can see that it is producing a rotational effect. So the same force now produces a turning effect, okay, about the fixed point. This turning effect produced by the force only is called as a torque. So when the string is pulled along the length of the cylindrical rod, it was not a turning. But at an angular position, when it is pulled either upwards or downwards means then it is producing a turning effect. Suppose when the string is kept upward and pulled means the rod is rotating in the anti-clockwise direction. Suppose if the string is kept in the downward direction and pulled means then it is producing a rotation in the clockwise direction. Okay, so that the string makes a angle theta with the direction of the position vector of one particle. So this turning effect produced by the force only is called as torque. It is also called by another name, that is called as what? Moment of a force. Moment of the force. And it is represented by the symbol tau. Okay, T-A-U. Tau. How to spell it is T-A-U, tau. So it is a Greek symbol. Now we want to get an expression for this vector torque in terms of two other vectors, namely position vector of one particle and the force vector. So now here you can see this irregular shape rigid body, this red color outline, now this represents a rigid body. Okay, so this rigid body is assumed to be made up of so many number of particles. So what is present inside the rigid body? N number of particles. Among them only one particle of mass m I have considered. So can you see here one black dot? No, that is a single particle, one particle of mass m. On that particle now, if I will exert a force F such that the force vector makes an angle theta with the direction of the position vector. So what is the position vector of the particle from the fixed point O? That is r vector. And what is the angle made by the force vector along the direction of the position vector? That is theta. Okay. Now I will resolve this F force acting on the particle into two components. So we have studied resolution of a vector into two rectangular components. So one component of this force along the position vector is F into cos theta. So this is F cos theta. And the vertical component of this force, which is perpendicular to R vector, so this is what F into sin theta. So this F cos theta, since it is acting along the length of the string, is it not? Along the length of the rod also, it does not produce any rotation. So which component is responsible for producing this rotation of this object? That is F sin theta. Understand? So it is found that the torque vector is found to be the cross product of the position vector and the force vector. So this is equal to magnitude of R and magnitude of F and sine of the angle between the two vectors into the unit vector n cap along the direction of rotation. Understand? So tau vector, torque vector is the cross product of the position vector and the force vector. Okay. Now what is the magnitude? What is the magnitude of this torque produced by this force? So I will write here magnitude of the torque. Magnitude of the torque is given by tau. Okay, tau without this vector symbol. This is equal to Rf sin theta. R into F into sin theta. Okay, so the torque, when will be this torque maximum? When will be this torque maximum? When theta is equal to 90 degree. And when will be the torque minimum? You see here, for maximum torque, if theta is equal to 90 degree means, so sin 90 is equal to 1, then the torque will be equal to R into F into sin 90 into sin 90. So this will be called as the maximum value of the torque. Okay, if theta is equal to either 0 degree or 180 degree, then torque will be equal to R into F into 0. Sin 0 is also 0, sin 180 is also 0. So this is the minimum torque. The minimum torque is equal to how much? 0. Okay. Now this RF sin theta, RF sin theta also can be written as R into F sin theta. In this picture, okay, in this picture it is clear that it is R into F sin theta. This may also be in another case. This also can be written as what? This is equal to R sin theta into F also we can write. Understand? So F sin theta, what do you mean by F sin theta? It is a perpendicular component of the force. What is R sin theta? It is a perpendicular component of the position vector. Okay, both. So this can also be written as R into the perpendicular component of the force, or perpendicular component of the radius, R perpendicular into F. Sometimes this position vector also is called as the radius vector. Is it not? Because the distance from the fixed point or the fixed axis up to this particle where the force is acting, no, it is also called radius vector. Why? Because when the entire rigid body is rotated, see here, when it is turned about this fixed axis, this particle after some time will change its position here, then it comes here, then here. Like this, the position of the particle is traced. So if you join the locus of the particle at various instants of time, can you see that it describes a circular path? Is it not? It describes a circular path. So I can say the position vector also by the name as the radius vector. Okay. So my dear students, what is meant by torque acting on a rigid body or torque acting on a single particle inside a rigid body? It is the turning effect produced by the force, and it is also called as moment of the force. Moment, the rotational effect produced by the force is also called as moment of the force. So it is given as the cross product of R and F. Already we have studied the cross product is also called as vector product, and the resultant vector which is the cross product of two vectors acts in a direction perpendicular to the plane containing the two given vectors. Is it not? So now you see here R vector and F vector. Okay. So I will take this is a plane. Okay. This is a plane, and here this is the axis. So this is R vector. Okay, R vector, and this is a F vector. So that this is the angle theta. Now when R vector cross product F vector is taken in the anti-clockwise direction, means then the tau vector will be upwards. Okay. Suppose if you take the cross product of the two vectors in the clockwise direction, suppose if this is the axis. Okay. So now here the body is rotating in the anti-clockwise direction. Now in the clockwise direction means then this is R vector. Okay. And this is F. So in this case the rotation will be in the clockwise direction. Understand that? But in both the cases, you can see in both the cases this tau vector, okay, tau vector is perpendicular to the plane of the paper, or it is perpendicular to the plane which contains the two given vectors R vector and F vector. So this is a direction of torque. So direction of torque is given by right hand rule or right hand screw rule. Right hand screw rule. We have studied, is it not, when a right handed screw is rotated in the anti-clockwise direction along the direction of the four fingers of our right hand, okay, then the stretched thumb gives the direction of the torque. Understand? So if R cross F is anti-clockwise, means then torque tau vector is upwards. Similarly, reverse it. When these four fingers are turned in the clockwise direction, means automatically you can see the thumb is in the downward direction. So this is a rule which is called as right hand screw rule to determine the direction of the vector, namely torque. Okay students, I hope you must have understood well. Fine.